In 1935, 9 out of 10 American farms had no electricity, none. Yet those workshops still forged plows, bored beams, sharpened saws, and rebuilt engines, all powered by one thing: a human arm turning a crank. These tools were not primitive. Some did jobs your cordless drill still cannot touch. Number 4 is the machine that built every other machine in America, and number 1 hung on a barn post for 80 years and still works today. Let's count down, starting with number 20. Number 20, the hand crank rope machine. Before nylon showed up on hardware store pegboards, American farmers made their own rope in the barnyard, and they made it for pennies. The machine was almost comically simple: a small cast iron head with 3 or 4 hooks, a set of gears, and a crank handle. Bolted to a fence post, hook the other end to a sled or a stake 50 feet down the lot, string out your binder twine, and turn. The gears spun all 3 hooks at once, twisting each strand tight. Then a wooden top, a grooved cone the size of a fist, walked backward down the length as the strands laid themselves together, and what had been loose twine became rope you could hang a hog from. A new era rope machine sold for around $3 in the 1920s. The twine cost a fraction of the finished rope, which meant a farmer could make 100 feet of half-inch line for maybe 15 cents. Kids were the labor. One turned the crank, one walked the top, and somebody's father stood in the middle shouting about tension. Oral histories from Iowa and Nebraska recall rope making as a fall chore done between corn picking and first frost. The whole family strung out across the lot like a tug-of-war team. Cheap imported cordage killed it. By 1955, nobody made rope anymore. They bought it. Number 19, the hand crank corn sheller. Every corn crib in America had one bolted to a plank, and every farm kid hated it. The single-hole sheller was a cast iron box about the size of a bread loaf with a flywheel on one side and a crank on the other. Feed an ear in the top, spin the wheel, and a studded rotating plate stripped the kernels clean off the cob in under 3 seconds. Kernels dropped into a bucket. The naked cob shot out the front like it had been fired. A Blackhawk sheller from the Foos Manufacturing Company in Springfield, Ohio, cost about $2.50 in 1910 and would outlive the man who bought it. Bigger farms ran 2-hole and 4-hole models with heavy flywheels. Get that wheel spinning, and momentum did half the work. Here's what people forget: shelling corn by hand, thumb against cob, was a full evening's misery for a bushel. The crank sheller did a bushel in 10 minutes. That flywheel was mechanical advantage in its purest form, and it fed the chickens, the hogs, and the horses that made the whole operation run. Oral histories from the Corn Belt recall the sound above everything else: that dry, rattling roar, kernels drumming into a galvanized pail, cobs piling up for the kitchen stove. Nothing was wasted, not even the cob. Number 18, the hand crank cider press. Come October, the press came out of the barn corner, and the whole neighborhood knew it. The classic American farm press was 2 machines in one. Up top, a hopper with a hand crank grinding drum, studded hardwood or cast iron that chewed whole apples into pomace. Below, a slatted oak tub and a threaded screw with a long iron handle. One person cranked the grinder, somebody else fed apples. Then you swung the tub under the screw and started turning, and the juice came out amber and cloudy and smelling like the entire month of October compressed into a bucket. A Hocking Valley or Buckeye press ran $15 to $20 in the 1920s. Serious money, which is exactly why one press served a whole road. Neighbors hauled bushels over and took turns. A good day produced 40 or 50 gallons, some of it drunk fresh, most of it barreled in the cellar to go hard by Christmas. Diaries from Pennsylvania and upstate New York. Record pressing day as a social event with a job attached. Kids cranked until their arms burned and were paid in the first glass. Refrigerated trucks and pasteurized gallon jugs ended it. Today, you can buy cider anywhere in America. You just can't buy that cider. Number 17, the hand crank wringer. Call it a laundry tool if you want. Every workshop had one anyway. Two hard rubber rollers in a cast iron frame, squeezed together by a heavy spring, driven by a crank and a set of gears, and it squeezed water out of anything you fed it. Lovell Manufacturing in Erie, Pennsylvania, sold them by the millions. A bench mount wringer cost about $4 in the Sears catalog around 1920 and clamped to a wash tub, a bench, or the side of a wagon box. Turn the crank, and the rollers pulled the material through themselves, and the operator's job was mostly feeding and not getting caught. That last part matters. The wringer was one of the most dangerous objects in American domestic life. Hospitals in the 1940s treated so many crushed hands and forearms that emergency rooms had an informal name for it, the wringer arm. Manufacturers added a release bar you could slap to pop the rollers apart, and it saved fingers, but it never made the machine safe. Shops used them for wringing out rags, dewatering leather, flattening gasket stock, squeezing solvent from cleaning waste. When the electric washer arrived with a spin cycle, the rollers went to the scrap pile fast. Nobody missed them, but nothing. Sense has squeezed water out of a canvas tarp the way those rollers did. Number 16, the hand crank meat grinder. It clamped to the edge of a bench, weighed 6 pounds, and it was the most quietly important machine in rural America. The Enterprise Manufacturing Company of Philadelphia was the name to have. Their number 12 grinder was cast iron, tinned, and built to grind a hog, not a roast. A hog. The mechanism was a steel auger in a tapered throat, driven by a crank through a worm gear. The auger forced meat forward against a rotating four-wing knife pressed against a perforated plate. What came out the front was ground beef. What went in the top was whatever the butcher couldn't sell. That was the whole point. In 1930, ground meat wasn't a product. It was a solution. Neck, shank, flap, trimmings, and the odd bits nobody wanted became sausage, scrapple, mincemeat, and Sunday loaf. An Enterprise number 12 cost about $3.50 and came with 3 plates, coarse, medium, and fine, plus a sausage stuffing horn. Oral histories from butchering day recall the entire routine. The hog hung, the water boiling, the grinder clamped to a plank table in the yard, and somebody's grandmother turning that crank for 2 straight hours while the men argued about sage. Slaughter moved to packing plants. The grinder went to the attic. Millions of them are still in attics right now. Number 15, the hand crank burr mill. Here's where the American workshop turns into a factory. The burr mill was a squat cast iron machine with a hopper on top, a crank on the side, and 2 grooved conical plates inside, one fixed and one spinning. Turn the adjusting nut and you close the gap. Wide open, it cracked corn for chickens. Screwed down tight, it made cornmeal fine enough for the breakfast table. A number 2 mill from Landers, Frary, and Clark, or a Sears branded model ran $3 to $5. Bolted to the bench, drop in shelled corn, and crank. The gearing multiplied your arm into something that could crush hard flint corn without complaint. But the mill wasn't just for corn. Farmers ground wheat, rye, buckwheat, coffee beans, dry peppers, salt blocks, bone meal, oyster shell for the laying hens. One machine, a dozen jobs, no fuel and no wiring. Here's what almost nobody realizes today. Fresh ground meal has the germ still in it, and the oil in that germ goes rancid in about a week. Store-bought cornmeal is degerminated specifically so it can sit on a shelf for a year. That's the trade. Shelf life for flavor. If you've only eaten supermarket cornbread, you have never tasted what came out of that hopper. Number 14, the hand crank magneto. Every shop had one, and every shop used it for something the manufacturer never intended. The magneto was a permanent magnet generator with a geared crank. Spin it, and it made real electricity, 60 to 100 volts of pulsing alternating current with no battery and no wall socket. Officially, it was a telephone. The crank box phones on farmhouse walls used the magneto to ring the bell on a party line, and the whole country learned to signal in rings. Two longs and a short meant the Hansons. Everybody listened anyway. Unofficially, a magneto pulled off a dead phone was the best electrical test rig a man without electricity could own. Mechanics used them to test spark coils, check continuity through a long fence line, find breaks in wiring, and fire off ignition systems on a bench. Ranchers used them to shock catfish out of a slough, which was illegal then and is still illegal now. And yes, they used them on each other. Grab the terminals, somebody turns the crank, and the entire threshing crew learns something about voltage. Oral histories from the 1930s are full of it. Initiations, dares, and one uncle who never fell for it twice. The Rural Electrification Administration made the magneto obsolete. It also made it a shop relic that still, 80 years later, works the moment you turn the handle. Number 13, the hand crank rotary machine, pattern break. This one you've almost certainly never heard of. Every tin shop in America, and there were thousands, ran a row of small cast iron machines with two rollers and a crank. Peck, Stowe, and Wilcox of Southington, Connecticut made most of them. Tinners called them rotary machines, and each one did exactly one thing. The burring machine turned a right angle lip on the edge of a disc. The turning machine rolled that lip into a hook. The setting down machine flattened the seam. The wiring machine curled the edge around a steel wire so a bucket rim wouldn't slice your hand open. The beating machine pressed a rib into a stovepipe for stiffness. Feed sheet metal between the rollers, crank steadily, and geometry happened. A tinner could run a milk pail from flat stock to finished in under 20 minutes. Cut, roll, seam, bottom wire, handle. A Peck Stowe burring machine cost around $12 in 1915, and a working shop needed 5 different machines to make one bucket. That was the American trade of tinsmithing, and it built every gutter, pail, funnel, dipper, downspout, and stovepipe in the country. Stamped steel and mass production erased it in a generation. The machines survive, mostly in antique tool collections, and every one of them still rolls a perfect edge. Number 12, the hand crank pipe threader. When indoor plumbing came to American houses, somebody had to cut the threads, and for decades that somebody stood at a vise with a ratcheting die stock and turned it by hand. Then Ridge Tool of Elyria, Ohio, and the Toledo Pipe Threading Machine Company built the geared hand threader, and one man could do what used to take two. The machine clamped the pipe in heavy jaws and drove a die head through a crank and a gear reduction. Turn steadily, keep the cutting oil flowing, and steel curled off in long blue ribbons while the die cut a tapered thread that would seal under pressure with nothing but pipe, dope, and torque. The skill was in the feel. Too fast and you tore the thread, too dry and you burned the dies. Not deep enough and the fitting bottomed out loose. A plumber knew by the sound and the resistance in the handle when he'd cut exactly enough, usually when the pipe end came flush with the face of the die. A hand threading outfit with dies for 1/2 inch through 2 inch cost around $40 in 1930, more than most men made in a week. It also meant a shop could run gas line, water line, steam line, and handrail out of the same stock. Threaded pipe built America's basements. A crank cut every thread. Number 11, the hand crank stitcher. In every town with a horse, and in 1910, that was every town, there was a harness shop, and in that harness shop sat a heavy cast iron machine with a crank on the flywheel and a needle the size of a nail. The Landis and the Champion stitchers sewed leather that no household machine could touch: bridle, collar, trace, saddle skirt, drive belt. The mechanism drove a curved awl through the hide, a needle followed, and a shuttle locked waxed linen thread into a stitch that would outlast the animal. The operator cranked with one hand and steered the work with the other, and the whole machine shook the bench. Here's the part that matters. This same machine kept American industry running. Before rubber V-belts, Factory machinery was driven by leather belting off overhead line shafts, and belting broke constantly. A shop with a stitcher could splice a driving belt in 20 minutes. A shop without one waited for the harness maker. A used Landis in the 1920s ran $60 and was the single most valuable object in the building. Then the tractor replaced the horse, the electric motor replaced the line shaft, and within 20 years the trade evaporated. Cobblers held on longest. Oral histories recall the smell more than anything. Leather, beeswax, neat's foot oil, and machine grease. Number 10, the hand crank saw filer. Second pattern break, and this one is controversial even now. A handsaw is a row of precisely bent, precisely angled teeth, and every one of them dulls. Before disposable hard point saws, you didn't buy a new saw, you sharpened the one you had, and the crank machine that did it was the Foley filer out of Minneapolis. You clamped the blade in, set the tooth count and the rake angle, and cranked. The machine indexed the blade one tooth, drove a triangular file through the gullet, lifted, indexed again. Every tooth identical. Every gullet the same depth. A crosscut saw that was sawing crooked went in and came out cutting like new in 15 minutes. Before that, filing was pure hand skill, a vise, a joiner, a saw set, and a man with a taper file and 40 years of eyesight. It took an hour and the result depended entirely on his hands. Here's why it vanished. In the 1960s, manufacturers began induction hardening saw teeth. Hardened teeth stay sharp about 5 times longer. They're also too hard to file. That was the whole strategy. A hard point saw cuts beautifully for 2 years, and then it's garbage, and you buy another one. Foley sold filers to a nation of men who fixed things. Then the industry made fixing impossible. Number 9, the hand crank winch. Pull a stump, stretch a fence, lift an engine, ride a tipped wagon, drag a dead horse out of a barn. Before hydraulics, before a tractor with a drawbar, the American answer to every one of those problems was a drum, a pawel, a ratchet, and a crank. The barn windlass was the oldest version, a wooden drum on an axle over the haymow door, cranked to lift loose hay by the forkful. The hand winch bolted to a wagon bed or a wall. And the come-along, the little cable puller with the 2-speed gear train and the folding handle, was the version every farmer carried. The numbers are the shocking part. A common come-along with a 40 to 1 gear reduction turns 100 pounds of arm pressure into 2 tons of pull. You are not stronger. You are just trading distance for force, 50 feet of handle travel to gain 1 foot of cable. And that trade is the oldest bargain in mechanics. A Vulcan or coughing hand winch cost about $7 in the 1930s. It had no motor, no battery, no fuel, and no failure mode except a broken cable. Which is precisely why every tow truck, every lineman, and every farmer in America still has one behind the seat. This tool never actually died, it just stopped being noticed. Number 8, the grindstone. Every farmstead in America had one sitting in the yard under a tree, and the good ones came from one place. Berea, Ohio. Berea sandstone was so uniform and so perfectly gridded that a single Ohio county supplied grindstones to the entire country and half the world, shipping them by the trainload. The rig was a sandstone wheel 2 feet across, mounted on an iron axle in a wooden frame with a hand crank and a tin water trough underneath. One person turned, one person held the tool. The stone ran through the water, and the water carried away the heat and the swarf, and the edge came up keen without ever burning. That's the detail modern shops lost. Sandstone cuts, cool and slow. A dry, high-speed wheel can ruin an axe in 4 seconds by drawing the temper. The steel goes blue, the hardness leaves, and it never holds an edge again. A wet sandstone wheel physically cannot do that. A grindstone rig from the Sears catalog cost about $4 in 1908. It sharpened axes, scythes, sickle sections, plane irons, chisels, hatchets, mower blades, and the kitchen knives. Oral histories recall the negotiation more than the work, because nobody wanted to be the one turning. Turning was the punishment. Holding the axe was the privilege. Number 7, the egg beater drill. Miller's Falls called it the number 2. Everyone else called it the egg beater because that's exactly what it looked like. A side crank driving a big open bevel gear, spinning a 3-jaw chuck at the bottom. It's the least glamorous tool on this list, and it may be the most perfectly engineered. Gear ratio around 4:1. Turn the crank once, the bit turns 4 times. A hardwood or cocobolo handle on top for your palm, a knob on the frame for your other hand, and inside the handle, a little compartment holding 8 drill points, so the drill carried its own bits. Goodell Pratt of Greenfield, Massachusetts, and Miller's Falls made the best of them. $2 and change in the 1920s. They drilled anything up to about a 1/4 inch. Pilot holes, hinge screws, sheet metal, small stock. Here's the case for it that no salesman will make. It has infinite speed control, perfect feel, no cord, no battery, weighs 1.5 pounds, and it will still work in 100 years without a single part replaced. It cannot strip a screw hole because your arm knows what's happening. Cordless drills are faster. That's the only thing they're better at. There are working Miller's Falls number 2s in shops right now that are older than the light fixtures above them. Number 6, the breast drill. When the egg beater wasn't enough, you leaned on the breast drill and let your body weight do the work. Same idea, twice the size, a 2-speed gear train, a 1/2 inch chuck, a side crank, and up top, a curved steel plate. That plate is the entire point. You put your chest against it, both hands on the drill, and pushed with 200 pounds of torso while your arm turned the crank. That's feed pressure a hand drill can't generate. And honestly, more than most people apply with a cordless today. The 2-speed feature was pure engineering sense. High gear for wood and thin stock. Shift the pinion to low gear for steel, slow speed, high torque, and the bit bites instead of skating. A Miller's Falls or Goodell Pratt breast drill ran about $5 in 1925. Bridge crews used them, boilermakers used them, wheelwrights, machinists, and farmers used them to bore steel plow beams and wagon iron out in a field where the nearest electricity was 40 miles and 18 years away. Diaries and oral histories from ironwork recall the ache more than the tool. A full day on a breast drill left a bruise across the sternum you could see. The drill didn't care. It bored 1/2 inch holes through cold steel, and it did it with a crank. Number 5, the hand crank bench grinder. Bolted to the end of every workbench in America sat a small cast iron machine with a crank on one side and an emery wheel on the other, and it was the difference between a sharp shop and a dull one. Luther's best made was the famous one. Cast frame, spur gear, multiplying your crank speed maybe 10 or 15 times, a 5 or 6 inch emery wheel, and an adjustable tool rest. $4 to $6 in the catalog. One man cranked while the other ground, or if you were alone, you got clever with a clamp and a knee. Emery is aluminum oxide with iron in it, and it cuts fast, much faster than sandstone. A hand crank emery grinder will burn a tool edge, but here's the elegance of the design. It burns it slower than you can panic. Your arm gives you feedback the moment the wheel loads up or the steel starts to grab. You feel the tool before you ruin it. The grinder shaped mower knives, dressed chisels, reground plow points, took the mushroom off a cold chisel head, and cleaned up every welded joint. When the fractional horsepower motor arrived in the 1930s, the crank came off and a pulley went on. Same frame, same wheel, just no more feel. Number 4, the Great Wheel Lathe, third pattern break, because this is the one that built everything else. A lathe spins the work and holds a cutting tool steady, and every machine in the industrial world traces back to it. In the American shop before electricity, the lathe was turned by a wheel, a wooden wheel 5 or 6 feet across with a crank handle, geared by a belt down to a small pulley on the headstock spindle. The ratio was the magic. 6-foot wheel, 6-inch pulley 12 to 1. One slow, steady turn of that big wheel by an apprentice sent the spindle around 12 times, and the momentum and all that mass carried the work through the cut smoothly. The apprentice was the motor and the flywheel at the same time. That machine turned chair legs, wagon hubs, tool handles, mandrels, bronze bushings, and iron shafting. Barnes of Rockford, Illinois, sold treadle-powered versions that let one man do it alone, and a Barnes velocipede lathe cost around $65 in 1890, the price of a good horse. Here's the fact that stops people cold. Every early American machine tool was made on an earlier machine tool, and every chain of that ancestry ends at a wheel turned by a human hand. The steam engine, the locomotive, the tractor, the airplane engine, all of it descends from an apprentice, a wooden wheel, and a leather belt. Number 3, the bit brace. It doesn't look like a crank. It is a crank, arguably the purest one ever made. A steel U-shaped sweep, a chuck at the bottom, a free spinning pad at the top, and nothing else. No gears, no motor, 1-to-1. Sweep the handle around, the bit turns once. What the brace gave you instead of speed was torque, and enormous amounts of it. A 10-inch sweep brace with a 1-inch auger will bore through 6 inches of oak beam with a mechanical advantage that a modern half-inch cordless drill has to strain to match. Push down on the pad with your chest, turn the sweep, and the auger's lead screw pulls itself into the wood. You aren't pushing, you're steering. Stanley's number 923 ratcheting brace was the standard, $4 to $5 in the 1930s. The ratchet was the genius part, and it's why the brace survived into corners and against joists where nothing else fit. Flip the cam ring, and you could bore in a quarter swing arc, working in a space the width of your fist. Every timber frame barn in America was drilled with one. Every mortise, every peg hole, every hinge. Oral histories of barn raising describe the sound of a dozen braces working at once, a slow, dry crunch, and long ribbons of shaving curling out of the hole. No cord, no noise, no excuses. Number 2, the hand crank forge blower. A forge without air is a campfire. Charcoal or coal burns at maybe 1200 degrees on its own. Force air through it and it climbs past 2500, hot enough to make steel yellow, plastic, and willing. For centuries that air came from bellows, a huge leather lung hanging from the ceiling that you pumped with a pole. Then the American manufacturers, Champion Blower and Forge of Lancaster, Pennsylvania, Buffalo Forge, Kennedy Auto, built the geared centrifugal blower, and the bellows was finished in 20 years. The mechanism is beautiful. A crank drives a gear train, usually around 16-to-1, spinning a fan wheel inside a scroll housing. 50 turns of your arm per minute becomes 800 revolutions per minute at the fan, and steady, controllable air goes up the tuyere into the fire. Not the wheezing surge of a bellows. Steady. A Champion 400 cost about $14 in 1920. That steadiness changed the craft. A smith could hold a precise heat, which meant precise welds, and forge welding is the one operation that has no margin. Too cold, no bond. Too hot, the steel burns into sparks and it's gone. Oral histories from country blacksmiths all describe the same sound, the low-rising whir of the blower, and the fire going from red to orange to a white you couldn't look at directly. Every horseshoe, hinge, plow point, and wagon tire in 19th century America came out of a fire fed by a crank. And finally, number 1, the post drill. Bolted to an upright timber in every serious American shop hung a machine that looked like nothing else. A tall cast iron skeleton with a spoked flywheel and a hump on top like an animal's spine. Blacksmiths called it the camelback. Champion, Buffalo Forge, and Kennedy Auto built them, and the design is a masterpiece of doing more with one hand. Turn the crank on the flywheel, that spins a bevel gear pair that drives the spindle. The flywheel's mass smooths every stroke, so the bit cuts continuously instead of chattering. That alone would be impressive. Then there's the part that makes it the best tool on this list, the automatic feed. A ratchet arm on the top strikes a star wheel once per revolution, advancing the quill a few thousandths of an inch every single turn. You do not push, you do not judge. Set the feed rate, clamp your work in the table below, and crank, and the machine drills the hole at a mathematically constant depth per revolution, which is exactly what a bit wants and exactly what a human hand cannot do consistently. That is a CNC principle executed in cast iron in 1890 with no electricity anywhere in the county. A champion, number 200, cost around $22, real money, and worth every cent, because it bored half-inch holes through wagon iron and plow steel all day without a single watt. The Rural Electrification Administration reached most of America between 1935 and 1950, and the post drills came off the posts. Some went to scrap, most just stayed, hanging in barns and back sheds, quietly not rotting. And here's the thing, go find one today. Wipe the dust off, put a little oil in the cups, and turn the handle. It works. It works perfectly. 130 years later, with no power, no parts, and no maintenance, it does the job it was built to do, because it was built by people who assumed nothing would ever be easy and made a machine that didn't need it to be. 20 tools, one idea. Not one of them needed a plug, a battery, or a repair shop. They needed an arm and someone who knew how to use it. Which of these is still hanging in your barn or your grandfather's shop? Tell me in the comments, and if you've actually used one, I want to hear it.